Hello my dear students, thank you for subscribing my channel. Can we start the class? Match the following. Quantum number is given, information provided is also given. Principal quantum number, significance of principal quantum number is size and energy of the orbit. A2 only one option is present. Azimuthal quantum number, significance, shape of the orbital. Magnetic quantum number, significant, orientation of the orbital. Spin quantum number, significance, spin of the electron. A golf ball of mass 40 grams and has a speed of 45 meter per second. If the speed can be measured with an accuracy of 2%, then uncertain in position will be. This question is related to Heisenberg uncertainty principle. This is the given data: mass 40 grams, velocity 45 meter per second. Velocity is given in terms of meters, so mass is taken in terms of kgs. Uncertainty in velocity is also given 2%. 45 into 2 by 100, so 9 into 10 power minus 1. H indicates Planck's constant. Planck's constant value you can take in terms of joules. Value is 6.626 into 10 power minus 34. Now question is calculate delta x. Delta x is equals to h by 4 pi m delta v. H indicates Planck's constant, 6.626 into 10 power minus 34 by 4 into pi value 3.14, mass 4 into 10 power minus 2, and uncertainty in velocity is 9 into 10 power minus 1. Simplify, then you will get the answer 1.46 into 10 power minus 33 meters. Third option is correct option. Select the correct match. First one indicates positive overlapping. Correct. Second one indicates zero overlapping. That is also correct. Third one indicates positive overlapping. Correct. Fourth one indicates positive overlapping. Wrong. In NCERT textbook already these diagrams are given. Once everyone please check. Correct answer is third option. In PCl5 molecule, the maximum number of planar atoms. PCl5 molecule undergoes sp3d hybridization. Geometry is trigonal bipyramidal. In PCl5 molecule, one central phosphorus atom and three equatorial chlorine atoms are present in same plane. So total 1 plus 3 is equals to 4. First option correct. Delta U naught for the combustion of CH4 is minus X kilojoules. Then the value of delta H naught is combustion of methane reaction. Methane undergoes complete combustion, then it gives CO2 and H2O. Here relation between delta H and delta U. Delta H and delta U. If delta N value 0, then delta H is equals to delta U. If delta N value negative, then delta H is less than delta U. If delta N value positive, then delta H greater than delta U. Now first of all calculate delta N value. Delta N is equals to Np minus Nr only for gases. Gases reactants, gases products consider. 1 minus 2. minus 1. Delta n value is equals to negative, then the value of delta H is less than delta U. Third option, correct option. Statement 1. Enthalpy of CaCO3 in its standard state is taken as 0. This is incorrect statement. Why? CaCO3 is a compound, not an element. Its standard enthalpy of formation has specific non-zero value because CaCO3 is a compound. Statement 2. Entropy of CaCO3 in its standard state is taken as 0. This is also wrong statement. Why? According to third law of thermodynamics, the entropy of a perfectly crystalline substance is 0 at absolute 0. The standard state refers to a temperature 25 degrees Celsius. At this temperature, all substances have positive entropy. At 298 kelvins, 1 liter vessel contains 2 moles of each A and B and 1 mole of each C and D. At the equilibrium, as per the equation, 2A plus B gives rise to C plus D. When the concentration of both reactants and products are doubled at the same temperature, the value of Kc will be, first calculate Kc. Kc is equals to PPC by PRC, product of product concentration by product of reactant concentration. So concentration of C into concentration of D by concentration of A, how many moles? 2 moles, so whole square, into concentration of B. 1 into 1 by 2 whole square into 2, that is equals to 1 by 8. Okay. Now what is given? When the concentration of both reactants and products are doubled at the same temperature, temperature remains same. We know that equilibrium constant depends only on temperature, not depends on concentration of reactants and products. So its value is 1 by 8 only. Conjugate base of CH3COOH is, conjugate base means to remove H plus ion from the given compound. From CH3COOH, you can remove H plus ion. Then you will get CH3COO minus. Correct answer is first option. pH of an aqueous solution of the following does not change on dilution. H2SO4. H2SO4 pH value increases on dilution. NaOH is a base. Base pH value decreases on dilution. HCl is acid. pH value increases on dilution. NaCl is a salt. So in aqueous solution, NaCl is dissociated like HClO plus NaOH. The given salt is the combination of strong acid and strong base. So pH value is equals to 7. Salt hydrolysis does not take place. pH value is fixed. The pH value is equals to 7. Number of significant figures in 0.0036 is 2. Assertion correct. Zeros preceding the first non-zero digits are non-significant. Reason is also correct. A is true, R is true, R is the correct explanation for A. Disproportionation reaction among the following is. What is disproportionation reaction? In a redox reaction, if same element undergoes both oxidation and reduction, then the reaction is considered as disproportionation reaction. Consider equation A. Manganese exhibits +7 oxidation state. Here manganese exhibits +6. Here manganese exhibits +4. Plus 7 to plus 6 and plus 7 is converted to plus 4. Plus 7 to plus 6 reduction process. Even plus 7 to plus 4 is also reduction process. First of all, this is not a redox reaction, so answer A is wrong. Take answer D. X is equals to 0, x is equals to minus 2, 2x minus 6 is equals to minus 2, 2x is equals to 4, x is equals to plus 2. 0 to plus 2 oxidation, 0 to minus 2 reduction. So only D is correct answer. Le Chatelier's principle is applicable to physical equilibrium, correct, chemical equilibrium, homogeneous equilibrium, even heterogeneous equilibrium also. Correct option, fourth option. 3 moles of electrolyte AB is completely dissolved in 94 moles of water at 298 kelvins. The relative lowering in vapor pressure at this temperature is P naught minus P by P naught is equals to I into mole fraction of solute, because I is introduced here because electrolyte is given AB type of electrolyte, or the above formula is also written as P naught minus P by P naught is equals to I into number of moles of solute by number of moles of solute plus number of moles of solvent. What is the value of I? I value is equals to 2. How? Want of factor is equals to number of ions present after dissociation or association divides with number of ions before association or dissociation. I value 2, number of moles of solute 3, number of moles of solute 3 plus number of moles of solvent 94. So 2 3s 6 by 97. No option. Wait. Remove I and calculate. Number of moles of solute is given as 3, but type of solute is AB type of solute. Want half factor is 2. So 3 is multiple with 2. Then you will get 6. P naught minus P by P naught is equals to number of moles of solute by number of moles of solute plus number of moles of solvent. 6 by 6 plus 94. 6 by 100. It can be written as 6 into 10 power minus 2. Assertion: limiting molar conductivity of Na plus is less than that of K plus at 298 kelvins. Correct. Na plus relatively more hydrated when compared to that of K plus. This is also correct. How? Na plus has a smaller ionic radius than K plus ions, resulting in a higher charge density. This causes it to attract more water molecules. So A is true, R is true, R is correct explanation for A. Which of the following order is wrong? Thermal stability order is correct. Boiling point order is correct. pKa order is wrong. Why? Acidic nature directly proportional to MH bond length. Acidic nature is inversely proportional to pKa. That means MH bond length is inversely proportional to pKa. But here given directly proportional, that's the reason it is wrong. Number of Faradays of charge required that can reduce 0.5 mole of dichromate ion to Cr3 plus ion in acidic medium. Dichromate ion is converted to Cr3 plus. Oxidation state of chromium in dichromate ion is plus 6. Oxidation state of chromium in Cr3 plus is plus 3. Oxidation number difference is 3 and n factor value. Left hand side chromium atoms 2 are present. So difference in oxidation number is multiple with 2, 3 to 6. If we can pass 1 Faraday of current, then 1 by k moles of substance is deposited. You can pass 1 Faraday of current, then 1 by 6 moles of substance is deposited. Instead of, but the question is different. Okay, sorry. If we can pass 1 mole, yes, if we can pass 1 Faraday of current, 1 by k moles of substance is deposited according to Faraday's laws. So k indicates n factor value. So we can pass 1 Faraday of current, 1 by 6 moles of substance is deposited. Instead of 1 by 6 moles, if you want 0.5 moles, how many Faradays of current is required? 1 into 0.5 divides with 1 by 6. 0.5 into 6, that is equals to 3. Correct answer is 3. For a first order reaction, the slope corresponding to a graph of log R naught by R taken on y-axis versus time will be, according to first order reaction, ln R is equals to minus kt plus ln R naught. We know that 1 ln is equals to 2.303 log. R is equals to minus kt plus 2.303 log R naught. Now entire equation divides with 2.303, then log R is equals to minus kt by 2.303 plus log R naught, or this equation is also written as kt by 2.303 is equals to log R naught minus log R. It is in the form of log A minus log B. Log A minus log B is log A by B. Log R naught by R. It is in the form of y is equals to mx. This can be written as k by 2.303 into t is equals to log R naught by R. It is in the form of y is equals to mx. So slope is k by 2.303. Half-life of a reaction is halved as the initial concentration of the reactant is halved. The order of the reaction is zero order reaction. T of is equals to R naught by 2k. First order half-life time. T of is equals to 0.693 by k. According to this, T of is directly proportional to R naught. That means half-life time is depends upon initial concentration. But in first order reaction, half-life time is independent on initial concentration. So correct answer 0 order, because half-life is halved, reactance is also halved. Assertion fructose is a reducing sugar. Correct. Fructose contains a keto group. Correct. A is true, R is true, but R is incorrect explanation of A. How? Fructose is a reducing sugar, no doubt, because in fructose, ketone functional group is present. The ketone group undergoes tautomerism and it is converted to aldehydes. We know that aldehydes gives positive Tollens and Fallings test. The substance which gives positive Tollens and Fallings test, the sugar is considered as a reducing sugar. The acid radical that can give rotten egg smelled gas with dilute H2SO4 is S2 minus. How? According to this equation. The sulfide of the following cation is precipitated only in basic medium. The cation is generally group 2 cations are precipitated in acidic medium because group 2 cations have low solubility product value. Group 4 cations are precipitated in basic medium. Group 4 cations are Ni2 plus, CO2 plus, Mn2 plus, Zn2 plus. Here Ni2 plus is given. So correct answer third option. Wrong match is take MnCN6 3 minus compound. In MnCN6 3 minus, manganese is in plus 3 oxidation state and its electronic configuration is argon 3d4. It is a octahedral complex, so T2G orbital is presented down and EZ orbital is presented up. T2G orbital energy is low compared with original d orbital and EZ orbital energy is high compared with original d orbitals. Cyanide is strong ligand field, so it does not follows Hund's rule. 3d4 1 2 3 4. Unpaired electrons are present or absent. Unpaired electrons are present, so it is paramagnetic substance, but here given diamagnetic, so wrong match is first one. The possible type of ions that can be produced by oxides of vanadium on treatment with acidic or alkaline solution is VO2 plus produced from VO2 in acid, VO2 plus produced from V2O5 in acid, VO4 3 minus produced from V2O5 in base. So BCD, A is not possible. Match the following. XeF4. XeF4 is a square planar complex. XeO3 sp3 with one lone pair, pyramidal. XeF6 distorted octahedral. XeF4 square planar 1b, XeO3 pyramidal 2c, 1b 2c. Second option correct. Which of the following acid has smallest dissociation constant? Smallest dissociation constant means value of Ka. We know that acidic nature is directly proportional to Ka and acidic nature is directly proportional to electronegativity. Chlorine is more electronegative element than bromine. So first two are ruled out. We know that acidic nature, distance increases, electron withdrawing group distance. Acidic nature is inversely proportional to electron withdrawing group distance. 1, 2, 3. At third carbon bromine atom is present. Here at the second carbon bromine atom is present. So third option is correct option. Which of the following does not exist? SiCl6 2 minus does not exist because Cl minus ions are larger than F minus ions. SiF6 2 minus is possible. SiCl6 2 minus is not possible. Highest ionization enthalpy is observed for. We know that ionization energy is directly proportional to stable electronic configuration. Helium electronic configuration is duplet electronic configuration and it is stable. So first option correct. Ti2 plus can liberate hydrogen gas from a dilute acid. Yes, this is correct statement because titanium SRP value is negative, means titanium SRP value is low compared with hydrogen SRP value, so it liberates hydrogen gas. E0 Sc3 plus by Sc2 plus is low value due to stability of Sc3 plus, correct. Sc3 plus electronic configuration is argon electronic configuration. This statement is also correct. E0 Ni2 plus by Ni is more negative than expected value due to low ionization energy, not due to low ionization energy. This is due to high enthalpy of hydration. So incorrect statement is third one. Which of the following options is correct? Lanthanide contractions is greater from element to element than actinide contraction. No, wrong. Actinide contraction is greater than lanthanide contraction. Lanthanoids can achieve higher oxidation state more easily as compared to actinoids. No, actinides achieves easily. PR3 plus ER3 plus SM3 plus PR3 plus ER3 plus SM3 plus ions are colorless. No, these are colored. Colorless is due to F0 and F14 electronic configurations. Remaining electronic configurations are colored. Once check the electronic configuration. So this statement is also wrong. On a reaction with boiling water, actinide gives a mixture of oxide and hydride. This is correct. The most suitable reagent for the following conversion is alkynes are converted to cis alkenes. Use Lindlar's catalyst. PDBaSO4 quinoline or PDC by quinoline. Third option correct option. Acetaldehyde and benzaldehyde can be differentiated using Tollens test. No, wrong statement. Why? Both aliphatic and aromatic aldehydes gives positive Tollens test. Acetaldehyde and benzaldehyde can be differentiated by using iodoform test or Fahling's reagent test. First statement wrong. Lassen's test for the detection of nitrogen will fail in case of hydrogen. This is correct. Why it fails? In hydrogen, no carbon atom is present. That's the reason cyanide formation is not possible. Statement 1 incorrect. Statement 2 is correct. Which of the following amine can be prepared by Hoffman bromide reaction but not by Gabriel thalamide reaction? Gabriel thalamide reaction, only aliphatic amines gives Gabriel thalamide reaction. Aromatic amines does not gives. In this aromatic amine is PHNH2. The next question is pairing energy is given, delta naught value is given, calculate crystal field splitting energy. Crystal field splitting energy is calculated by using the formula minus 0.4 into x plus 0.6 into y delta naught plus np. P indicates pairing energy. N indicates number of paired electrons, number of pairs. It is a octahedral complex. H2O is a weak Ligand field. So it follows Hund's rule. Before configuration 1, 2, 3, 4 minus 0.4 into 3 plus 0.6 into 1 delta naught value is given as 15800. N represents pairs. Here all are unpaired. N value 0, 0 into anything, this value is 0. So minus 1.2 plus 0.6 into 15800, that is equals to minus 0.6 into 15800. Simplify, you will get minus 9480. The final product C obtained in the reaction is NH2 group is treated with acid anhydride. Acid anhydrides reduce the activity of NH2 group. Then it gives a amide NHCOCH3. It is in the form of RCONH2, amide CH3. This is a amide. The amide name is acetanilide, which on further reacts with bromine. Activity of NH2 group is decreases because now beside nitrogen a strong electron withdrawing group is present. Now reacts with bromine. Substitute. First preference is para position. Para position is already occupied with CH3. So substitute bromine at ortho position. Further hydrolysis. Remove CH3COOH. Then it gives NH2 Br CH3. Correct option, fourth option. Cannizzaro reaction is given by aldehydes without having alpha hydrogens. Alpha hydrogen atoms. Example, formaldehyde, benzaldehyde. So the correct answer is fourth option. The treatment of CH3 taken twice, C double bond CH3 with hot KMnO4 by H plus produces. KMnO4 by H plus acts as strong oxidizing agent. Alkaline KMnO4 is Bayer's reagent, dihydroxylation takes place. Now, strong oxidizing agent, double bond left side look like Cr2. Cr2 parties get oxidized to ketone. Shortcut this is. It gives CH3COCH3. Double bond right side, CHR part is present. CHR part is converted to RCOOH, that is CH3COOH. Which option is correct option? First option. Follow the hint. The name of the following reaction. In Getterman reaction we are using CO plus HCl. Getterman Rosenman reduction we are using PDBaSO4. We are using CrO to Cl2 in Ettard reaction. The correct order of bond dissociation enthalpy of halogen is Cl2 greater than Br2 greater than F2 greater than I2. Fluorine bond dissociation energy is very low compared with chlorine. Generally, bond energy is inversely proportional to bond length. Here exception is fluorine. Fluorine atoms are extremely small, so between fluorine atoms interelectronic repulsions are present, so bond energy is decreases. Number of structural isomers possible for the molecular formula C5H11Br. Total 8 isomers are possible. It is there in haloalkanes and haloarenes. NCERT textbook questions. Meta-directing functional group. All these are electron withdrawing groups. Electron withdrawing groups are meta-directing functional groups. These are electron donating groups, ortho and para-directing groups. Correct answer is fourth option. For the reaction, N2 plus 3 moles of H2 gives rise to 2 moles of NH3. dNH3 by dt is equals to given 2 into 10 power minus 4. Then calculate value of minus dH2 by dt. According to the equation, minus dH2 by dt is equals to 3 by 2 into dNH3 by dt. dNH3 by dt value is given as 10 power minus 4. 2 cancel. So answer is 3 into 10 power minus 4, fourth option. Formaldehyde reacts with Grignard reagent. Then it gives alcohol, 1 degree alcohol. Break the bond between CH3MgI. Mg gets positive charge, CH3 gets negative charge. Break the bond between carbon and oxygen. Oxygen negative, carbon positive. Then it gives HCH, CH3, OMgI. Which on further hydrolysis, H plus OH minus. Oxygen gets negative charge, Mgi gets positive charge. Remove MgOHI, then it gives CH3CH2OH. Correct answer, ethanol. Choose the compound which is more acidic than phenol. Orthonitrophenol is more acidic than phenol because NO2 group is electron withdrawing group. Electron withdrawing group directly proportional to acidic nature. CH3 and OCH3 are electron donating groups. Acidic nature is inversely proportional to electron donating groups. Last question. Which of the following reaction is a halogen exchange reaction? Second option. There are two halogen exchange reactions are there. One is Finkelstein reaction. Second one is Schwarz reaction. In Finkelstein reaction, iodo compounds are the products. Schwarz reaction, fluoro compounds are the products. Thank you.